All right, everyone, we're going to go over the mathematical use of a logarithm. Hopefully from the video, you got a little bit of an understanding of what a logarithm is. In science, logarithms are used to calculate really large numbers or really small numbers. We're not going to do that. We're going to focus on just average everyday numbers, but in our world, most people use logarithm calculations when dealing with really large or really small. What does a log mean? It means if you have log base b, any number equals k, then the base of this to the power of that equals this number. So, of course, that sounds super confusing, but we're going to talk about it in a second. In the computer world, every logarithm is in base 2, whereas this one's in base 6. So I don't understand computer code as some people do, but in the computer world, all logs are calculated in base 2. So if I look at this, log base 2, what this means is, log base 6 is that 6 to the power of this number has to equal that number. So, of course, 6 squared equals 36. Now, let's check the next one. So, all I'm asking you to do is take it from a logarithm and write it in exponential form. So, you're not doing any math. You don't need a calculator, nothing. So, here, I know that 2 to the power of 1, this base to this power equals that number. So, 2 to the power of 1 equals 2. Here, base 10 to the power of, and it's always to what's after the equals 1,000. Now, the only thing I want to talk about real quick, in the science world, which is most of the time what they use is log base 10. So I just want to explain, you're most likely going to see this from here on out like this. There is not going to be any base here. And when the base is missing, that is a base 10. So because it's so popular in the science world, anytime they write a log without a number, then it's always base 10. So even though it's on here, you will see from here on out that most likely it would look like that. And that shows you that it is base 10. So let's go down. I think the next one asks you to go the other way. Okay, so now here I give you the exponent, the exponential equation, and I would like it back to a logarithm. So what I'm going to do is I know we're going to have a log. The base is always the big number. So here I know it's going to be log base 3. Then remember, it's to the power, and that's always after the equals. So it's this base to after the equals this number. So where my equals is this base to that power, 3 to the power of 4 equals 81. So I'd like you to pause the video, and I'd like you to try these 4 in the practice. So go ahead, take a second. This is switch out of the notes and go down to the 10-4 practice. And I just want you to do 1, 2, 3, and 4. And right here, all you're doing is rewriting it into a logarithm. So pause the video, do that real quick. So for the first one, you should have just been able to say 14 to the power of 2 equals 196. 19 to the power of 2 equals 361. Here, I'm going to say 19 to the negative 2, which remember, if it's negative, it's the reciprocal of, so it's 1 over 361. And then here, your last and very easy one is base 3 to the power of 2 equals 9. Okay? Now I'd like you to scroll down. And I'd like you to do these 4 in which you put these 4 back into a logarithm. So go ahead, pause the video, try them first, and come back. So here what I'm doing is I see that it's the log, the base is always this number, but it's to what power? 3 over 2 equals 27. So here I'm going to do log. Now I'm not going to put the base because like I've already talked in the video, if it is base 10, we don't really need a number, but that base to that power equals 0.001. So that one I'm going to make it look like that only because what I told you, in base 10, they don't normally write the number. Log base 2, so this would be maybe something in the computer world. Okay, so however computer code's written, they're going to use log base 2. So now you can see, just check yourself, is the base to the power equal the number? Base to the power equal the number. Is 2 to the 5 32? Then yes, we're done. Check. Okay, good practice. Go back to your notes. Now here comes the math on how you need to be able to figure out what a logarithm is. So if I look at this problem, the directions I want to point out say solve/evaluate. And the reason I put evaluate is because if I ask you to solve something, it normally has a equal sign. Anytime you're required to solve something, you're finding an answer with an equals. So there is no equals in this problem. So really the directions should say evaluate. But what we're going to do is write equals x because that's where our variable is. This is what we want to find. So once we write equals x, we are then going to set up an exponential equation. Base 5 to the power of x equals 25. Now, hopefully a problem like this, you could tell me 5 to what power gives me 25. But if not, you remember back to our index card that we did, 5 to what power gives me 25? I know it's 5 squared. Other way to do this is I could put 5 equals, and then I could look this up and say 5 squared. That's what 25 is. 5's cancel, and x is 2. So that's the reason we did same base. For this one, obviously, like I said, if you obviously could figure out that 5 squared is 25, you could have put x is 2 and been done the problem. So however you want, but what you need to be able to do is when given a logarithm, be able to take base to a power equals a number. Okay, so let's look at these two. I'm asking you to evaluate/solve. The reason I say solve is because I'm going to write equals x. And once I do that, then it's an equation, and then you can use an equal sign. And then you can solve. So go ahead and try these. Pause the video, try them by yourself. 2 to the power of x equals 8. So 2 to what power equals 8? If you still have your index card, 2 to what power? Here's the 8, so the power is 3. So I'm going to go back and say x is 3. Now, if you much more break it down and you want to do 2 to the third so that you understand, and then x equals 3, however it helps you. Here is 3 to some power equals 81. I'm going to run to my index card. 3 to what power gives me 81? Answer is 4. And now we have another logarithm. Here the problem is it's the base that's the variable, but that's okay. We're just going to see when we make our equation, it's in a different spot. So here it's still base to some power equals 36. So here, this is the one where we would raise this to the 1/2. Hopefully you could figure out what number squared is 36. If you had to go back to your index card, 36 is here. So squared, the number is 6. So obviously my answer is 6. Mathematically, if you needed to solve it, we would raise this to the 1/2 to get x. And 36 to the 1/2 is the square root of 36, which is 6. So if you could not figure that out, you could do it mathematically. All right. And then we have 2 more similar to that. Let's look at these 2. Okay. Again, the base is x, some power to 6. Again, this is going to be some number raised 6 times 64. This number better be really small. You could raise this to the 1/6. You could raise this to the 1/6, but our answer is 2. If you needed to, go to the index card. 64 is right here. Some number 6 times is 6. So these, are supposed to be fairly easy. This one's going to be tricky. This is definitely a tricky problem. So x to the 3/2 equals 27. Okay, here's definitely tricky. This is what we need to do. We need to raise this to the reciprocal so that it becomes out x, because that's going to become a 1, and that's what we want. Whatever I raise it to, I need to raise this one to. Well, this is now your rational exponent. So down here, I'm going to raise this 3 to the 3rd. That's what 27 is, to the 2/3. Then that's going to be 3. 3 times 2 is 6, so that's going to become 6/3. 6 divided by 3 is 2, so this becomes 3 squared, which is 9. Definitely a tricky one. Okay, we're always going to put one tricky one in there. All right, what I would like you to do is go to 10 for practice, and I'd like you to scroll down, and I'd like you to do, let's say, the first 6, okay? 11, 12, 13, 14, 15, 16. Try those, please. Pause the video. Of course, the first one's a little challenging. Let's skip 11 and look at 12. 7 to the power of x equals 343. So all you're doing is finding 7 to what power is 343, and our answer's 3. In this one, 5 squared is, 5 to what power is 25? Our answer's 2. So these are very easy. 6 to the power of x, x is 3. Now let's look at 11. 2 to what power is 1/16? Well, what I'm going to do is make it 2 to what power is 16 to the -1. Then I'm going to keep this as 2 to the x, but I'm going to change 16 as 2 to the -4th. And that's when I can cross my 2's out. Let's look at this number 15. It's a little similar. 4 to what power is 64? Now, if you know that, fine. If you don't know that, and I go back to my index card, 4 is not on there because 4 is really 2 squared. So I'm going to change this to 2 to the 2x, and then I'm going to change 64 to 2 to the 6. Now I know they're both in the family of 2's. 2's are going to cancel. 2x equals 6, and x is 3. So that's how I'm going to do that one. Here, 7 to the x is 7. Don't think too hard about this, right? 7 to what power is 7? X is 1. All right, so that's an example of some of those. Hopefully you could get through the rest by yourself. I'm going to look down just at 21. Here, the base is 7. It's giving you 2, so 7 squared is x. 49 equals x. So it does not matter where I put the variable in a logarithm. It's always going to be base to the power equals the number. Base to the power equals the number. Okay, and 4 times 4 to the 3rd is 64. Okay? All right. Have a good day.